Hello, test. You guys hear me?
Yes,
Oh, great. So how's it going?
everything's good.
Good. So yeah, so we got two people here right now. So these I've been putting up these lecture videos, so I mean these will definitely be more driven by questions and stuff if we keep doing them here. So I know you were the two of the three or so people that had replied to the email. So um well but yeah, we can go ahead and start. I mean if you guys have anything that you kind of want to ask about or would like me to start off with, or how are the assignments coming? I know one of you was working on the assignment, was mostly done for the first one,
Yeah, for thank you for your email last night. I already solved the problem with the issue with the vectorized function,
right?
and now I'm working the assignment too.
No, really? Okay.
But but I had just a comment for the lectures on the recorded lectures. It seems like the fonts are too small to see.
Okay, I'll check those. Yeah. So on the lecture slides in particular, or
Yeah, the when you're showing the notebook in Jupyter.
oh, when we're doing interactive stuff on the notebooks,
Yeah,
that's yeah, I should check that. But yeah, definitely it's easy to increase the size of the screen. So yeah, thanks. I'll try to remember that. So,
I think that's all for me. Thank you.
okay.
Yeah, hi sir, this is Özlem. Uh, I didn't started yet watching the video, so I will about to start today. So due date is the tomorrow, right? I
Yeah, for
remember.
it's tomorrow. So we'll usually have probably two each week, one on Wednesday and then one on the weekend. Be due. So, yes.
So we will have the 8 assignment totally, right? Or
Well, that would be 10, although, yeah, I'm thinking, well, for one, I'm not certain I can get all 10 done here. The other is our fifth week is going to be, we actually end on like Thursday, so it might be just one on the last week and then like a final exam, a final test. So nine or 10 or maybe eight or seven. I might only do one for some of the last week or two, depending on how big they end up being for the assignments.
oh, okay. So I have the only one question. So there is the video link is the very long for assignment one week first. How long? I mean the which videos I need to watch it. I I'm so a little bit confused because I checked yesterday night and I didn't understand. Uh, so
So I mean, basically for assignment one, well, to tell you the truth, I mean, assignment one, you can probably, get started on just as long as you know some Python and stuff. If you've done some Python NumPy stuff, you'll probably jump into it without doing a lot of the reading. But basically the stuff that is kind of related to the first assignment. So the stuff when you're looking at the content. The one above the assignment would be the materials that are usually going to be related to the assignment. So for the first half of this week, that would include basically the chapter one and two introductions, kind of from our deep learning with Python book. So the chapter one is more of just a big picture. What is deep learning and how does it relate to machine learning and stuff like that. And cha chapter two is kind of important. We have one or two things that directly link on chapter two, maybe to assignment one, but chapter two is trying to build up some intuition about I mean, what tensor operations, what they do geometrically, how you interpret those, and kind of what that means for a neural network that's basically applying those kinds of transformations from the inputs to the output. So yeah, those would be the basic readings. There's lecture notebooks in the assignment repository that go with those. So I encourage you while you're watching the videos to have the notebook open and actually be running the stuff, So the links for if you haven't seen that, the links for the course repository is there under the class resources. So that has a GitHub repository that you can clone and start working with the materials. That has all the lecture notebooks and all the slides and everything that I'm going to be using for the class content.
Oh, okay. So this class resources wasn't open yesterday to me, but today is fine. I see now.
Okay. Sorry about that. Yeah, it should have been open. I don't know when, but yeah, okay.
Yeah, maybe Google Chrome is working now. I tried yesterday Safari. I'm fine now. Thank you.
Sure. Let's see. Well, I mean, I won't keep these too long. I think I will, even though I haven't had specific questions on it, because at least this first video, I am going to also post it kind of this first help session kind of after the fact. So I'll say one or two things about the first assignment. There is a video. So again, I'll point these out. If you look at the playlist for the class, the first three videos. There should be a third one now. I need to move that one up there. So the first three videos are kind of really setting up your environment. So I hope everybody doesn't have trouble setting up their environment. I hadn't had anybody ask me about that, but you can start by looking at that if you're still working on that. But yeah, you do need to have that done and be sending me questions if you're struggling getting Docker and VS Code. I mean, I highly recommend that you do use the development environments that we're expecting for the class. It's not 100% required. You could install Python natively on your host system. Just if you do that, just make certain that you are using pretty much the same versions of the libraries. Maybe I'll show that real quickly here for the assignment. But yeah, the second one kind of shows you a little bit what you need to do in order to do the assignments. So for anybody that's maybe watching this after the fact, this will be a bit of review, but let me just show that real quickly. I've already accepted the assignment personally, but whenever you want to work on an assignment, you go to the assignment. There should be an invitation link for this GitHub Classroom. When I click, you'll see something different if you haven't accepted it yet. Well, I guess I haven't here. So you should see your name on there, and you make certain you select your correct name. That should create a repository for you. So this is the thing that you need to clone in order to get started working on the assignments.
You mean the assignment repository creating, right? Or the GitHub community class?
That the step that I just showed you creates a GitHub repository for you that you should work on your assignments on. So in particular, since I've already created another way to get access to that, I showed that in the video, but from your GitHub account, let me just go to my GitHub account.
I think I have already that one, so maybe.
Sure. I could double check it for you, but from your GitHub account, you should be, if you go down and look at your organization, once you started working on assignments for this class, you should find that you're a member of the 560 summer organization, NNLDL summer organization. So if you look in there, you should find your repository that will get created when you accept the assignment. So you won't be able to see the other people. So I can, sorry if I'm embarrassing anybody. So I can see, it looks like probably most everybody looks like it's accepted assignment one at this point. But anyway, you should only see your assignments. They are private, except for me, I can see them. But that's where another way you can get back to your assignment repository if you need to find it again. So from this, you do need to clone the repository. Maybe I'll just show that real quickly. If you've got your dev containers and everything set up and running, I'm going to go ahead and delete my old version of this repository so I can re-clone it. So for me, since I cloned it before, you can always just delete and then re-clone if you find you're having problems.
Harter, I see just me and Abraham is colon this assignment one. Are you able to see whole classmate in there?
Yes. Yeah. So, I mean, I can see that it looks like most everybody has accepted the assignment, which is good. Maybe most people are past the kind of step that I'm talking about here. So,
Oh, okay. So I think I did the wrong thing, but it's look
the,
like
the names, okay, yeah. So the two names that were on there were people that hadn't accepted yet. So you need to accept your name the first time when you go to that, and select your name when you accept the assignment. So,
okay. Thank you.
um, all right, yeah. So, yeah, once you've accepted the assignment and created the repository, if you've got your GitHub set up and your Docker running, you should be able to clone it like I'm going to show here. So I'm going to clone that URL. You should clone the SSH URL. So it'll be something like git@github.com. You want to clone it from the URL. Don't use the second option. This is asking for a location on your local file system to save the files into that it downloads. I suggest I always put it in a subdirectory called repos or something like that personally. So the way VS Code works, if you're not familiar with that, it uses folders on your system as like a project. So you want to always open your folder. That'll be kind of the idea of working on a project in VS Code. If Docker and stuff is set up, it should give you the option to reopen in the container. So you want to do that. And now that I'm thinking this, if you've never created a Docker container before, it might take some time to do that. A bunch of stuff has to download and things. Mine came up really quickly. It's already running because it caches stuff. So the second and subsequent times you create Docker containers, it should usually be faster for you. So once it's running for you, it actually runs a Jupyter Lab server for you. So like I showed in the video, one way to get your Jupyter Lab server, if you want to use the web-based interface, is if you open up your nohup.out file, you'll see a link to the server. This has like the token, the password you need in order to actually log into the server. I usually just double click on that so I can get in and work on my assignment. So here's our assignment one. Um, So normally you should there might be some assignments where I have more than one notebook, but for the first couple of weeks, there'll be just a single notebook, which is where you'll do your main work. When you first start an assignment, when you look at this notebook, it should run. So if I like rerun everything from top to bottom, I do that a lot. So I usually don't want it to keep bugging me that I really mean to restart. And
Professor, are you sharing your screen?
oh, I'm sorry.
Oh, no, right? Okay, sorry.
So there we go. So yeah, missed all that. I wasn't sharing my screen. Sorry about that. This is after the point where I had actually cloned in GitHub. So maybe I'll kind of reshow that. So after it cloned successfully and runs and is running in the container, you should be able to get access to your Jupyter Lab server by opening up the nohup file. Then if you look in there, you can usually just click on that like that. So control click on that link will open up your Jupyter Lab. I prefer using the web-based interface. There should be extensions set up in these projects for you so that you can actually use the note. You can actually edit and run the notebooks inside of VS Code too if you prefer. So either way should work. So anyway, back to this. What I was showing here was I usually recommend once you first start off, make certain that the notebook is running. So I usually just rerun all the cells. So it is normal. So I'll just talk about this here. So the normal thing you're going to be doing is looking for these places where there's tasks to do, and then you have to write code so that you pass these tests for the tasks here. So normally when you first start off, this was my assignment when I showed in the video, I actually showed completing the first task here. So the first task is actually successfully running and passing all the tests. But when you first do it, it won't be passing. So like the second task here, when it tests, it's running the test, but all these here are actually failing. The cell finishes and it does the next cell, but it fails to pass all the tests for the second task here. But I can see that the notebook actually ran if I go all the way to the bottom and look at the last cell. The last cell actually did run as well, although again, it's still failing all these tests here. So, so yeah, the reason why this first one is passing on my assignment, I did show this in the second video where I kind of showed this workflow. So I'm really quickly going over some of the stuff that I talked about in that video here. In particular, like this first task here. So I just open that up. So when you first start this assignment one, the first task, if you read this, is you have to write a function that when you pass in a string like this, it needs to return a new string that says something like hello, whatever the string is that you pass in. Right? So that's what the first function is supposed to do. So initially, all the functions that you write for these kinds of cells where there's a tested function are actually going to be in our assignments in the source subdirectory of the project called assignment tasks. So initially, when you get this code, when you check out this assignment, your hello world probably will look something like this. It will just return an empty string. So if I was to rerun the cell with that function, it's telling me that when I ran the tests, it failed all these. So in particular, in this one, it failed because it was expecting a string called hello George, but it actually received the empty string. It takes a little bit of of experience kind of reading the output from the unit test running here, but that's what's happened here. A unit string was returned. The test was expecting that you return that. That's the same thing for all these tests here. So in particular, to get your first task finished and running, you have to return hello plus the string plus an exclamation mark. That's what the test, and again, if you read the description, that's what it's expecting. All right. So here, I always recommend, it is a requirement that every time you finish a task like this, that you make a commit, push it to your repository. So I haven't checked yet on the people that have been doing assignment one. Hopefully everybody's doing that. Maybe I'll try and check that here to give some feedback on people's repositories to make sure everybody's doing that. So here, since I want to make a commit now of my first task, let's go ahead and make a commit. I recommend that before you make a commit that you go ahead and rerun every cell. So make certain that the stuff that you did is actually working, passing tests, and that the whole notebook is still running everything from top to bottom. So yeah, I mean, I usually use VS Code nowadays because it's got a pretty nice interface in order to do your source control to do Git. So here, if I go back to VS Code, what I expect is I actually made a modification here. I was expecting a modification in my assignment task as well, but actually I just changed it to be the same as it was before. So for example, let's make another modification in my assignment tasks. So I had finished this function, but let's say I added some comment. So now if we look at our source control, maybe I have to refresh it here, we'll see that there's two files that are currently modified that I made changes in. And this is the diff function inside VS Code is kind of nice. So for example, if I want to know, okay, what did I do there? I can click on that inside the source control. I can see, well, I actually modified this line. I added some things to the comment here. I think this works with the notebooks if you have the extensions installed. So let's see. Oh no, well, yeah, you just get a diff of the raw JSON file, so that might not be too helpful looking at the diff. You can mostly only tell. Well, I guess that's the metadata. Yeah, I guess it does try to do some attempt. So yeah, it is showing the kind of the cells. Anyway, but yeah, so these two files changed. I want to go ahead and make a commit out of those. So I'll go ahead and just add both of those to a commit. So here we do put in a good commit message. So you should obviously have a title followed by a blank line, followed by a sentence or more of description to give a hello greeting. Something like that. I'm not really too worried about the content of the commit messages. I just want people to get in the habit of actually giving commit messages that are meaningful, that have a title and say something about what's in the commit. Um, so once you make a commit, it's not actually pushed yet to GitHub. So before I can see it, it actually has to go up to GitHub. So here the purple things are actually on GitHub, but this one is still local. So you should be able to sync it. Sometimes this doesn't pop up here for some reason, even though you have local changes that haven't been pushed. So you should always be able to look down here at the bottom. So here's the status for my current GitHub repository. I've got nothing on my remote repository that hasn't been pulled down yet, but I do have one local commit that needs to be pushed back up. So if I push down here, it should do the sync as well. So. All right, so just when you do that, the result should be, if you go back and look at your repository, so an important thing to look at when you're doing these assignments is the pullback, is the feedback pull request. So that is what I mainly see as the result of you pushing your work. So whenever you do push a commit back up here, that's when I can see it. And I can see what you did. So this is what I just did right now. Finished the task one to give a hello greeting, but also kind of importantly, those same tests that are run locally that you're trying to pass are run in the auto grader in GitHub as well. So it's still running the tests here. So we can watch them running in action here. I'm not certain that because for this class we have to install a lot. So the setup takes some time. So I'm a bit worried once I get to some of the assignments in week 3 or 4 that it's going to end up being a little bit more than the auto grader is going to allow on GitHub. So we'll see. But right now it's still installing all the setting up Conda, installing the packages. It hasn't even started running the test yet. So we'll leave it here and see if it eventually gets there and runs them. So, but you want to always check. So whenever you create a commit, you'll want to always go back here and make sure that it successfully runs and that it's passing the test that you think that you completed successfully on your local environment. All right. Well, I mean, the other thing is I might, give some hints on these, although, for this class, I'll get some hints on the task maybe for this assignment 1, if I don't have any specific questions on them. I see, like I said, it looks like people haven't been getting going. That's great. So I did see that quite a few people have accepted assignment 1 and a few people are working on assignment 2 already at this point. Going back to the tasks here for the assignment, another thing I like using on the web interface of the Jupyter Lab is the view, so you can get an outline of everything that's in your IPython document. So after that warm up, hello world one, there's like what, 5 functions in the second part here to write. Now, these functions we'll be reusing them in assignment 2 and throughout the course. So, kind of knowing what a sigmoid is as an activation function. We'll be doing a lot of stuff where we reshape tensors. So that's kind of the first step before you can build a neural network, is you have to get your input data into the right shape. So this image to vector, which is the third task on the second part here, is very common that you have to do in order to do image processing or so our third week of the class, we're going to look at specifically deep neural networks for doing image processing. So like things like convolutional neural networks and things like that. But let me go through these one by one. So the sigmoid, if you're not familiar with that activation function, so that'll be one of the things you'll learn about in chapter 2 a bit, but actually you'll get more of that in chapter 3 this week. What activation functions are. That we do talk a little bit about that in chapter 2, where we're talking about how tensor operations or matrix operations, kind of the how you can interpret those geometrically, what they're doing to your data. So the last thing you normally do for a layer of a neural network is you run it through a nonlinear activation function. So a sigmoid is a common one. So this function you need to implement in a vectorized way. If you give an input X or an input Z, you have to do this function on it to get this output. So the sigmoid function squashes the output. Whatever the X or the Z is, from negative infinity to positive infinity, it squashes it to a number from 0 to 1. So, again, like all of these, so whenever you have these, that's a tested function, that's going to be in the assignment tasks source file. So I usually like to use VSCode to edit source files because it's better at editing than trying to edit stuff in the Jupyter Hub notebook, Jupyter Lab notebook. So again, our assignment task here. So the first task for the second one is that sigmoid. So for all these, if it's not clear, all you're doing for this week is I give you the function and a description of it, the Python documentation for the function. You should remove the return statement and add in your code, but you do have to return the result, right? So you need to return the correct sigmoid calculation for the input X, not 0. But yeah, I skipped over, or I said a little bit wrong here. So the first one, you're supposed to actually implement it in a non-vectorized way. So the basic sigmoid you should be implementing by writing a loop. So that was the first one. I'm sorry, not writing a loop, but using the math library instead of using NumPy. So math is non-vectorized versions of like the exponential function and other functions. So yeah, kind of the important thing, if you don't know, familiar with what I mean by vectorized functions and using NumPy, the first two things are trying to give you some intuition for what it means to write a vectorized function using NumPy. So the second version of the sigmoid, you're supposed to write it fully vectorized. So you shouldn't be using the math library. You need to be using the NumPy library to do that kind of thing. And we will get into, so in the second assignment, you'll have to do some stuff where you're calculating the gradients of some functions. Like this one here, though, we will usually kind of give it to you. You won't have to derive what the gradient is. So we'll give you a pretty big hint, or basically what you need to do in order to calculate the gradient. So in this case, if you need to know the gradient, which is the slope or the derivative of the sigmoid function, you can calculate it by just multiplying the sigmoid times 1 minus the sigmoid. So that is an expression for the gradient at some instantaneous point here. So, you should be reusing your vectorized sigmoid function for this sigmoid gradient one here for this first assignment. And then there is, I looked at this one a bit, so we will be doing something. You have to write another version of this again in like the second assignment or the third assignment. So this is, if you're familiar with NumPy, this is about reshaping arrays so that they're a particular shape that you need for training image to vector. In the fourth one, we actually build the so this is just normalizing the rows here. So hopefully you can follow the description of the stuff to be done here. Need to check my mouse scrolling here. It's a little bit too fast. So yeah. So I mean, this one I thought we explicitly said this is basically the softmaxed function that we're doing here. So what's happening here, we'll run across the softmax function a lot and use it a lot in this class. So this is an actual implementation of doing the softmax activation. Oh yeah, so we did say that, right? So it is the softmax. So let me go back to my feedback pull request, finish up the thought there. So here you can see that it finished. I mean, until you get the complete assignment done, you won't get your green check mark. That's kind of what you're aiming for, but we can go back and see what happened when it ran the autograder here. So currently I'm getting a 20 out of 100 because if you look at it, it'll always run a first test to make certain that the notebook runs cleanly. Okay, so this won't pass. Again, this won't pass unless, if you run all the cells from top to bottom, and if it stops somewhere before running all the cells, you won't be passing that test. So you always need to be submitting a clean notebook. And then after that, though, these individual tests should be the same ones that you have locally, right? So we were passing the Hello World one, but we haven't finished any of the tests yet, any of the tasks yet in part 2 of the assignment, the basic sigmoid and the sigmoid gradient. So once you get all the tasks done, you should find that these are all passing. And you'll get a green check mark and you'll get 100 in the notebook here. All right, and just to finish up my thought on that, so there was like a third part implementing some loss functions, L2 and L1 loss. These are basically for people who take machine learning, for me, or have previous experience with it. So L2 is really just another name for the mean squared error. And it's also related to L2 regularization. So they're both using the square of the difference. So so one of the functions so the two functions are implementing the loss function. So L2 or the mean squared error is the one that we'll usually use when we're doing a regression problem. So when we want the output to be some single real valued number. But sometimes the L1 loss, which is really just the sum of the absolute values, is used. So these two functions for the last one should be pretty similar, but in the one case you use the np.abs function, which I think was given as a hint here, to do a vectorized absolute value of some of these values. And in the first case, you need to take the square of these functions. Although, again, as a hint here, you could do this kind of directly as is shown here, but you can actually use a matrix multiplication. So a dot product between the two vectors is equivalent if you first compute the difference, the error. So if you do the dot product of the errors with itself, that's equivalent to doing the square of these errors here. Okay, yeah. Let me stop talking there. So that was just a real quick things, just uh, descriptions of some of the tasks. So let me open it up again. I've got a couple people here now, a couple more. Anybody have other topics or questions they want to bring up? Or any doubts about things? I'm sure if you have them, some other students might have them. So
I have only one question, the professor. I'm sorry. In Visual Studio, where we are finding the opening the Jupyter Lab link, could you show one more time, please?
what I normally do, I'll show a couple methods on this. So if it's running, so for one thing, if it's running, if you have your terminal view open, you'll see that one of the terminals is the result at the end of starting up the Docker container. So the command it runs to do Jupyter Lab is that. And you should see that as one of the open terminals here, right? So the Jupyter Lab is running. Another way you can tell it's running, if you look at your ports, you'll see that there's a port open on port 8888. Okay. So if let me go back and close my running notebook here. So if I need to open up my notebook, one method is if you look in this nohup.out file, um, so the output from running Jupyter Lab is sent to this nohup.out file. So one of the things that's in that file is the link with the token you need. This is really kind of like the password. So in VS Code you can like control click on that, and that should open that up in your default browser. So that will get you into there.
Oh, this is for assignment one. Okay, I'm looking the class video, class the repository inside, and I don't see anything here.
Um, yeah, I mean, for any repository you open, if your dev container is running, check. I mean, if if Jupyter Lab is not running and you're not in your dev container, you won't have a nohup.out file. So that's created only at the very end of getting the container started up and running, right? So check these things. I mean, do you see like your ports? Do you see something open? If you look in your terminal, do you see that you've got the configuration terminal still running, which indicates that the Jupyter Lab command is currently running inside the container in the background on there. So yeah, I mean, if that is running, there should be a nohup.out. So you should find that at the top level of your in the file explorer.
Oh, okay, okay. I remember now. Thank you so much.
So yeah, once you find, I mean, you do have to have that because basically it generates a random token. So that's the password to get into it. So I think I already showed this here, but I often, kind of as a shortcut, I often copy that token and just open up the port here. And then I reset my password to something so that if I re-log in, I can just reuse that little password. Although, did that work? I don't know if that worked. So if I do it again, it just went directly to it. So yeah, I guess let me try just logging out. Let's go there again. Oh. Yeah, there we go. So yeah, I've got my short password now for the Jupyter Lab server. That should be persistent over stopping the container and restarting it, I hope. So. All right. Yeah. Anybody else want to ask anything? One or two new people joined while I was talking. Okay, well, yeah, I mean, I'm gonna go ahead and in the session, unless anybody wants to jump in. I don't know whether I'll do these sessions or not. I might do another one again on Thursday to see how people are doing on the assignment two, to see how they're going. So feel free to, always feel free to email me. I can always set up a session face to face on Zoom, or I am on campus if anybody needs anything. So, okay. All right. Thanks a lot. Yeah. Good
Thank
luck.
you, Professor.
Sure.
Thank you, Professor.
Yep. Great. I will see you guys. Hopefully I'll see you guys around. Keep working on stuff. See you guys later.